Okay, so let's discuss the new notion of a sample. Okay, so from now on, sample is actually a set of samples. Okay, so sample is not just a single observation, but it's a set of observations. Okay, so that is called a sample. So I mean, again, one sample is a set of multiple observations that we collected. Okay, so that is, please don't get confused about it. And then in order to call such a set of observations as a sample, so we need some assumption. So we require some assumption, and such an assumption is our observations starting from x1 through xn are independent random variable, and also they should come from the same distribution. Okay. So does anyone know another name that we call this situation? Did anyone heard about this IID? IID. IID. What will be the full name of this IID? Yeah, so this is independent and identically distributed. Okay, so independent corresponds to this part, and identically distributed means they came from the same distribution. Okay, and in that case, these set of observations are called a sample. Okay, and then the sample, when considering the sample, we first consider it's a larger set that we imagine, which is called this population. Okay, so population. So you can think of the situation as follows. So suppose we want to obtain the exact ratio between male and the female people living in this entire world or entire Earth. Okay, and then in order to have the exact measure or exact ratio between a male versus female, we should count all of these people available in living in the world, right? But in practice, it's not possible. Right? So such an entire set is such an entire set is called population. Okay? But we can never obtain the entire information of this population, but we only obtain a sample or a set of the collected people. Okay, so we, for example, maybe give a call to a random number and then ask whether he or she is a male or female, and that way we collect a set of samples, and then we can consider this kind of random sampling or picking up a random kind of a phone number can be viewed as this sampling from independent and also identically distributed distribution or random variable. Okay. Okay, and then from this limited number of samples, limited number, a sample that has a limited number of observations, we can infer or guess the ratio between a male versus female, right? Yeah, so that is the overall story. And then what we usually want to do in this process is we want to have although it is an approximate process because we only use only a subset of this population or a small number of observations, but we want our desired the ratio between a male versus female to be approximately the same as the true ratio of male versus female, right? And so Such a process is called a kind of an inference. Okay, inference, and then we can think of the true but unknown value of the ratio of male versus female. Okay, and then such an unknown but true value, true but unknown value, is usually called this kind of parameter. Okay, so this is a parameter, and then inferring or kind of guessing such a parameter value by using a sample which is composed of a small number of observations. So that is called this parametric inference. So it's like a guessing. Okay. So it's a mathematical and a fancy term of guessing, but our guess is based on a little bit of a principled or well-designed processes. Then if our distribution doesn't have any kind of parameter, and then it is called this kind of non-parametric inference. Yeah, so in mathematics or data analysis or statistics or machine learning and many of these academic literature, there is a kind of categorization of a parametric method or non-parametric method. So it has a really diverse meaning depending on different areas. But But anyways, you can just understand within this context about this parameter, and in this case, we don't have such kind of clear or specific definition about what we want to obtain. Okay, so in this case, it's a kind of non-parametric inference. And then what are we guessing in this case of a non-parametric inference? What do we guess? So it is something like this. So suppose, let's consider the person's height. So we still consider the entire people living in the world, and then consider their height. Okay. So in that case, suppose that is that follows the Gaussian distribution of maybe 170 or 165, and maybe the variance of 10 squared, or standard deviation as 10. And then, can you draw the full shape of our distribution by only using these two values? And the answer is yes, because we know that distribution is following the Gaussian distribution. So Gaussian distribution will have a certain shape, and then in order to exactly specify that shape, we only need those two numbers. Right? So that is kind of a parametric kind of a class or parametric distribution. Okay, so only using a small number of parameters or those constant numbers, then we can recover the full shape of distribution. So that's when we call it as a parametric distribution. In the case of a non-parametric distribution, it's not having a special kind of function definition. So you guys remember what are the probability density function definition for Gaussian random variable and the exponential random variable, Poisson random variable, and also chi-square distribution. It all has its own definition for its probability density function. But in some cases, the density function is not even defined as one single formula. Okay. Yeah. So one representative example is kernel density let's see. Yeah, Google can fix this. Oh. Okay, let me see. Okay, so in this case, I'm not sure if it's a good example or not, but suppose you have collected your height information from maybe 10 different people, and then you can think of some small kind of a small hill or small mountain is formed around each of 10 height values. So in that case, suppose we collected 170, 165, 180, for example, and then we put a small mountain centered around those 3 values. So we put 3 mountains, and then the sum of these mountains will have some shape, right? So that can be viewed as some distribution as long as their sum or area under this curve to be 1, so that it can satisfy the probability density function. Right? So in this case, if we can define the density in this manner, and then our density function will have those number of mountains as the same as the number of our observations. Right? So in these cases, the density can be defined, but this density cannot be represented as a single formula. So in this case, we call it as a non-parametric probability density function. Yeah, so in this case, the well-known kind of method is called a kernel density estimation. But anyways, it's a realm of machine learning. But yeah, it's time's up. So let's continue next time, next Thursday. Thank you very much. 네. 아까 내가 온 거 봐서